So looking at the vector multiplication of two vectors in 3D, we can be able to establish the fact that for 3D vector, we can consider vector multiplication when we look at matrix application. You have to understand how a matrix or how to deal with matrix before you can multiply vectors. Okay? If you understand how to multiply matrix, then we can be able to solve problems concerning vector multiplication. So we're going to look at some example, and okay, this one have to do with angle between two vectors. We have dealt with this. Okay, the vector product. We look at how we can multiply them using multiplication based on matrix application. Okay, in matrices, we understand in our matrix classes that we can solve the multiplication of two matrices by using what we call sectional multiplication. Okay, let me just look at one example. We are given a matrix of this nature: 2, 1, 3, 4, 5, 2, and 3, 2, 1. And we are looking for the determinants. Determinant of matrix A. To find the determinant of matrix A, we use multiplying. You can use what we call the Saros Rule or the Saros Rule to do that. So we applied that. We have 2. Taking this, you know, you are going to take this. Okay, so we have 5, 2, and 2, 1. The minus 4 with this, because we have plus, minus, plus. And minus 4, we have 1, 3. You don't take numbers under and by the side. So 1, 3, and 2, 1. 2, 1. Then this one is plus 3. And we have 1, 3 again. Then 5, 2. So when we cross multiply each of those sectional value, looking for their determinant. So we have reduced this into 2 by 2 matrix. This is 3 by 3 reduced to 2 by 2. So we have 2 in brackets. 5 minus 4. Minus 4 in bracket 1 minus 6. And plus 3 in bracket 2 minus 15. So that will give us 2 brackets minus 1. Minus 4 in brackets minus 5. Then plus 3 in brackets minus 13. So we have minus 13. We have here minus 2 plus 20 and minus 39. So minus 2 plus 20 is 18. 18 minus 39. So 18 minus 39 is 1 and 2. So you have 21. So here the modulus or the determinant of vector of the modulus of A is 21. So we applied this in solving problems in matrix. In matrix multiplication, that is vector multiplication. So from the basic deductions, if we want to find the product of two vectors, then we use the matrix method, which is the analytical expression of the product of two vectors A and B. So the product of two vectors A and B can be gotten by using the matrix method. So let's look at example. When we have vector A is given by 2i plus 3j minus 4k, and matrix B is I minus 2j minus 3k. I want to look at the product, vector products of A and B. How do you find that? That means A multiply B. You know, when we talk about scalar product, we say product. That means dot. Scalar product is given as, what is it? Scalar product is equal to A dot B. But vector product, we say A cross B. You can call it cross or times. So that will be equal to this vector 2i plus 3j minus 4k cross product I minus 2j minus 3k. And that is equal to modulus of ijk. Ijk. So since this comes from, so we have take their coefficient 2, 3, minus 4, and 1 minus 2, minus 3. So you arrange this in this form and you simplify using vector analysis. So we have using matrix analysis. So we have I, taking your numbers, we have 3, minus 2, minus 4, minus 3, and j, we have minus j, and that minus j will give us 2, 1, 2, 1, minus 4, minus 3. Then we take for k, plus k, we have again 2, 1, and 3 minus 2. So when we do the multiplication, that will be equal to I in brackets minus 9. You cross multiply. Minus, this is 8. Then with the minus, you have minus 8. Then minus j in brackets. This comes here, we have minus 6. This multiply, you have minus here, minus 4, so we have to turn to plus 4. Plus k in brackets. This multiply this, you have minus 4. With a subtraction, we have minus 3. So you simplify further. Minus 9 minus 8 is equal to minus 17. So you have minus 17i. Then minus 6 plus 4 is 2 with minus. So you have minus is plus. So you have plus 2j. And here we have k. Minus this will give us minus 7. So you have minus 7k. So this is the answer for the vector product of A and B, given this example. So we look at this using your matrix analysis technique. So with that, we can solve other problems that are related to that. We can also find the angle between the vectors if we apply the vector notation concept. When we look at the vector notation concept using scalar product, for scalar products, we apply this. That means for scalar product, we say vector A and B can be multiplied and look for the angle between them. Using that, you have A dot B is equal to A vector dot B vector cosine theta. That means cos theta is equal to A dot B vectors divided by A vector dot B vector. But recall that unit vector of A, that is unit vector of A, is equal to A unit vector with a cap on the A. So that means A unit vector is vector A divided by modulus of A. So that means we can deal with this and say cos theta is unit vector of A with a cap, multiply B with a cap. So we can do this. This is for scalar multiplication. But for vector multiplication, instead of considering the, what's it called? The vector multiplier, vector product, instead of considering that, we look at the A and B as given as A dot B vector is equal to A vector modulus multiplied by B sine theta. So that means sine theta is equal to A dot B divided by vector A multiplied by B vector. So we can use this to solve sine theta, the sine of angle between them. So we can also use this to find the angle between the vectors. Okay, if we consider that apart from using the sine. So that's what we are trying to show here. And we use sine theta equal to that. We find that and find the sine theta of that angle to be root 26 over 29. So we can solve a lot of problems related to that and look at the application of vector products. One of the applications of vector products is that we use it to find the area of the parallelogram. Area of a parallelogram. To find the area of a parallelogram, you talk about the vector product. And the product of two lines equal to 0 will give us the area of the shape that is given. Okay, so when we consider the area of the shape, we look at, for example, find the area of the parallelogram with adjacent side. A is I minus j plus k, and B is 2j minus k. So that means the value of I is missing there, so it will result to 0. So you see the multiplication. Once we multiply it, it gives us the area of the parallelogram. We can check another example as follows. We talk about find the area. Find the area of the parallelogram. Parallelogram with sides. With sides A equal to 2I plus 3J minus 5K, and B is equal to 4I minus 3K. So to find the area of the parallelogram with this, okay, we consider the parallelogram to be of this shape. We have something of this nature, and this is your A and B, and this is the angle between them. So for us to find the area of this shape from your geometrical analysis, area is AB sine theta. So you see that we are applying the same concept of looking for it. So if we want to do that, we solve this by saying A is given as this. So we find the area by using the vector product. So A dot B is the area of the shape. So that area A is equal to 2I plus 3J minus 5K cross product 4I minus 3K. So you do that, we have IJK, and we have 2, 3 minus 5, and here we have 4. 3K here will be 0, and here is minus 3. So when we simplify that and we find the modulus, the absolute value, we'll get the answer to that. So if we want to do that, we can solve by saying that is equal to I modulus 3, 0, minus 5, minus 3, and J minus J modulus 2, 4, minus 5, minus 3, and plus K, and 2, 4, 3, 0. So when we simplify that, we have I in brackets. We have 9 minus 9 plus 0, minus J, minus 6. This is minus 6 plus 20 plus K. In brackets, we have 0, minus 12. So final answer, we have minus 9I, minus 9I. You have plus 20, that will be 16. Okay, 16. 20 minus this will give us 14. So you have 14 plus 14J. Okay, it will be negative. So we have minus 9I. Okay, and this is positive here, the negative. So you have negative 14J, that is minus 14J. Then here we have minus 12, minus 12K. So if you have gotten this as the vector notation for the area of the parallelogram, then we can find the what we call the modulus, or the absolute value of that, and that is equal to this in units. So that will be square root minus 9 squared minus 14 squared, that is plus with minus 14 squared, then plus again minus 12 squared. So with this, you get the answer to the area of the parallelogram that is given. So with that going forward, we can look at other examples of this. We look at exercises that have been attached to the what you are given, so you can solve and look at the answers are also attached to there. So in summary, we can talk about the vector product using the matrix technique, and we have some short questions that we can solve with respect to that. Okay, so and the objectives, we can solve all those problems. But before we go, we are going to look at the relationship between vector and coordinate geometry. Briefly, we look at how we can relate vectors and coordinate geometry. Okay, in coordinate geometry, you talk about a point in an XY plane. For example, we're looking at 2D. In an XY plane, a point, this is a point, P, and here is Y and X. Okay, so we're given P as this point X and Y. That is point X, this is point 0. So that means P in vector form is given as xi plus yj. Okay? But in ordinary form, let's assume that here is 2 units and here is 3 units. That means P is represented, P point xy is represented as 2, 3. 2, 3 because OX unit is 2 and OY is 3. So we can do this. And if you want to find 2 points that are between 2 points, you have now the vector form of this is this. So if you want to see the vector form of this coordinates, we call it 2i plus 3j. That means we can convert from vector notation to ordinary coordinate geometry notation. So that means if we have something like P vector is equal to 4i plus 3j minus 5k. That means the vector in coordinate geometry form is given by vector 4, 3, 5. Or we can also write it in this form. Vector 4, that is the geometry 4, 3, and minus 5. So that means what we have here and what we have here are the same. So if you are given a coordinate geometry for number that point, or maybe OA, is given as 3, 4, 7. You can represent this in vector form and say OA is equal to 3i plus 4j plus 7k. So that is the vector form of this. And you can also use it to find the distance between 2 points using a vector application. So we also consider that when we get to coordinate geometry, we look at in coordinate geometry how we can relate vectors and coordinate geometry. So in subsequent classes, try to join the class and you'll learn more of that. So that is, thank you for listening.